Hi, I'm recording this video for my GCSE Electronics students in Year 10. We've just done a quick progress test for systems and a few of you are going to need to do a retest, so I'm going to go through the paper, tell you what the answers are, try to explain these again, and then hopefully if you do the retest you're going to get them all right. So first question then, following is a list of electronic subsystems and you have to put all of these subsystems into either input, process, output. So you would actually write your answers in just to make the video quicker. I'm not going to write them in. A buzzer is an output. It must be because it converts an electrical signal into an output sound. So write buzzer in output. A latch unit is neither input, it's not something like a switch or a light sensor. It's not an output because, well, it doesn't output anything, but what it does is it takes an input, so like you might have a switch, and then it goes into a latch, which then once it, say maybe for example takes a logic high, then it's going to latch on and stay on until it's reset, and the reset switch, if it were a switch, would be another input, goes to the latch. And then the output, well, what's it going to latch on? I don't know, a solenoid, a buzzer, a lamp, whatever it might be, okay? But the latch unit is definitely a processing system, so we've done those two. So you would write latch unit there, okay? Delay unit, similarly, it's going to be started by some form of input, but the delay is a processing system. Maybe it's going to be delayed for like 5 seconds or whatever, and then that might say turn a lamp on or an LED on or a buzzer on or whatever for 5 seconds and then go off. Okay, so delay is processing. Light sensing unit, hopefully you can you will just know that a light sensing unit is an input system, so it converts or will be used as part of the processing system to convert the light into an electrical signal. A lamp unit converts the electrical signal into light, so that's output. So lamp unit is output. Temperature sensing unit, yeah, I think you really should by now be able to figure out that one's input. And the OR gate does some processing. Maybe like there might be 2 switches. If either of them are pressed, then we need to process that and then perform some output. So an OR gate is going to be processing. Let's hope you can get all those right. If you get all 3 columns right, you get 3 marks. Right, the next one. If you want to pause the video now, you can read through. I don't want to take too long, so I'll give you just a moment. Pause now. Okay, I'm assuming that you've now unpaused, so we're going to design a system. This is system block diagram here, and we've got a number of potential subsystems that we can put into these. So all of these things, we can use any of these. You can use them more than once as well, so you don't really need to cross them through. What's it going to do? Well, it's going to pulse this LED on and off when the soil is too dry, but only during daylight hours. Okay, sorry, I think that was off camera there. So pulses only during daylight hours when the soil is dry. Now the light sensor, if you read through this carefully, you'll see that the light sensor, and we need that light sensor because daylight hours, outputs a logic 1 when in daylight. That's going to be important to us. And temperature sensor, nothing about temperature, so we don't need to know anything about temperature. Soil too dry, moisture sensor outputs, so moisture sensor outputs logic 1 when wet, but we want when it's dry, logic 0 when dry. So if we want to say it's going to be daylight and it's going to be dry, well, dry is 0 and daylight is 1, so we're going to have a daylight and not on this, because we're going to need to change this 0 to 1, because if you do 1 and 0 the output will be 0, but 1 and not 0, in other words 1 and 1, is going to be output 1. So the moisture sensor is going to go here. I'm just going to abbreviate this. You should write the full words, okay? Moisture sensor goes here, and then the NOT gate will go here. the light sensor. Once again, do write the full words here, okay? I'm just making this a quick video. That's going to be an AND gate, and then the pulse generator is going to basically go on, off, on, off, on, off. In other words, 0, 1, 0, 1, like that, okay? And each time, well, let's say if the moisture sensor, when dry, it outputs 0, so not 0 is 1, and when the light sensor does a 1 because it's daylight, 1 and 1 is 1, and then when the pulse generator outputs a 1, then presumably then you want something to happen here, you want the LED to turn on, so we need another AND, okay, because 1 and 1 is going to output 1, and then they've got this thing here. Now you may recall in the lessons I've said that a transducer driver is, or a transistor or a MOSFET, but we haven't studied those yet, so don't worry if you don't know what they are. Transducer driver, let's just use that term for the moment, is always required if you're driving a high powered device like a motor or a heater or something like that. Well, an LED isn't a high powered device, but they've given us this box. Now, it's actually correct that they've given us this box, because when you use a logic gate, really, strictly speaking, you should use a transducer driver. Now, remember, a transducer driver just converts one form of energy, or rather, a transducer converts one form of energy to another. So LED converts an electrical signal into light. A transducer driver is just the thing that drives that transducer driver. Now, you could, if you wanted, to connect an LED straight to an AND gate. There are good reasons why you might not want to. I would prefer not to explain that just at the moment, because that will be a later topic. Now, if you look through here, you won't see a transducer driver, but you'll see transistors. At this point in the GCSE course, we haven't studied transistors, so you're just going to have to take my word for it. And I think I pre-warned the class that if you saw a transistor, then that is a type of transducer driver, so you're going to write transistor switch unit there. Okay, as I say, do write the full words. I'm just initializing it, whatever, like that, just to make this video quick. So that's the first two sides. Question 3. Once again, take a moment, click pause if you want to read the question. Okay, hopefully you've taken a quick read of the question, and you will understand that this is an alarm system, and the alarm system is going to sound a siren. The siren is going to, sound periodically with each pulse of the pulse generator, so it won't be like it'll be like that. Pulse generator is going to be outputting zeros and ones all the time, and ideally, if this were a good system, you would expect if either of the doors were entered, then the siren would sound periodically, like that. But, however, when Michael tests the system, it fails to operate correctly, because basically if you close either of the two doors, then the siren won't sound anymore. By the way, avoid saying the siren won't go off. If you say the siren won't go off, what does that actually mean? It's quite ambiguous. I know we'd often say, oh, your car alarm's gone off, but does that actually mean it's sounding, or it's no longer sounding because it's now off rather than on? So very, very ambiguous actually to say that. If either of the doors are opened, it tells us here logic 1. So for example, maybe that's a 1 and a 0, and then the OR gate, that's going to output a 1. But as soon as you then close this door, then that will go to 0. So that goes to a 0, and a 0 and say a 1 will be a 0, so the siren won't sound. Not what we want at all. We need to describe the effect of this latch. So there's a latch here, this time on the side door, and what we could say is that if the side door is open, the system functions properly, the alarm will sound even if the side door is closed. So hopefully you can see that the side doors, even if it's closed, because as soon as you got logic 1, that's going to latch on and stay on. However, if the main door is opened, the alarm will sound, but only while the main door is open. As soon as it's closed, the siren will no longer sound. Now you need to say something along those lines. If you say that, then you can get the 1. They don't give you a lot of room for that, do they? Part B, what have we got here? Well, it's not really in the right place, is it? Because previously you had a 0, 1, 0, 1 and a continuous pulse of those zeros and ones. But if you use a latch, as soon as you've got a logic 1, the latch is then going to latch on and it will stay steady state of logic high or 1. If either of the, or if the side door or the main door are opened, the siren will sound continuously. That's the word you want. Don't just say it will be on. You will say it will sound continuously with no pulsing. Okay, so you can say continuously, should be quite clear, but if you said continuously with no pulsing, that would be good. But as soon as the doors, both doors are closed, the siren will no longer sound, or you could say the siren would be silenced. Okay, should get marked for that. And once again, they don't give you a lot of room, do they? This one actually is the correct one. If either of those two doors are open, so let's just open that door, so logic 1, with the OR gate, that's going to output a logic 1, which is then going to latch on, and then that goes on and then stays on. So what we can then say is, if either the side door or the main door are open, the latch will stay on, the system will function properly, and the alarm will sound in time with the pulse generator, and that would give us a mark of 1. I do know it's a little bit tricky writing a good answer for these. You've got to bear in mind there's only 1 mark for each one, so long as it looks like in your answer you understand, I think you would get the mark. Okay, these are unambiguous, it has to be exactly right. Same for these as well. The only thing I would say is possibly if you wrote transducer driver, but I don't think so. You really have to write transistor switch unit because that's what it says, and it says use these, not use your own ones. Okay, if you're going to redo the test, good luck. Hope you get top marks next time. Thanks for watching.